All right, hope everybody's doing well. Today we wanted to bring you another LifePo battery. This one's made by DIGI MARKER. It's a LifePo4 12.8 volt battery and kind of a odd size, 135 amp hours. This will fit into various different areas better. You know, a 200 amp hour battery is pretty huge. 100 amp hour is a decent size, but this one is kind of right between that, 150 to 100 amp hour, and this might have its own little niche for powering small things. We can tell you right off the bat, the case is extremely well built. It feels good. The handles are solid and built in. We're definitely liking that. Easy to pick up and store. Weighs about 25 pounds, the battery. Came with hardware and caps. So you get the screws, you get the caps. And again, the case, it just looks phenomenal. This case feels good, feels durable. Spin it around, and we'll look right here. So we got the nominal capacities, 135 amp hours, 1728 watt hours, charging voltage of 14.4. So what we're gonna do is we're gonna leave it on this side so that we can be reminded of all this stuff. Actually, you know what? Nah, we'll flip it around here. We'll remember what it is. We'll take a look at it. So what we're going to do is we're going to get it hooked up to the shunt, and we're going to fully top this thing off and see where it's at. Before that, let's just look over this instruction manual real quick. It's a nice little booklet. Tells our whole story here. And they've got plenty of batteries. You got a 6 amp hour, 8 amp hour, 15 amp hour. That must be their factory. 30, 50, 100, 135. So that's where we're at right now. And there's all the specs. So this is a max charging of 50 amps and discharging of 50 amps. And the max inverter load is 640. So we will definitely check that. And they got batteries that range in 24 volt. So 200 amp hour batteries. Low temperature heating. I don't think this model has it. But here's all the settings for the MPP charger. How to make your connections in series and parallel. So definitely an informative little book. We'll see exactly what it's about and see if this battery is worth anything. Alright, so the battery came in charged at 13.19, right about where it's supposed to be. So the shunt is saying 74% charged. It's probably not accurate because it hasn't been calibrated to this battery yet. But if you do see there, we do have the 100 amp hour remaining there, and we did set it up for 135 amp hours. So maybe it did self-calibrate, but we'll hook the charger up here and we'll start pumping about 30 amps into it. Alright, so we'll just let this thing charge up and go from there, and then we'll test and see what we can discharge out of it. It does say in the manual that you cannot use over 600 watts, maybe 700 watts. Let's check here. Alright, as you can see there, 135, 640 watt max load inverter. 1500 watts, not gonna work. Alright, it's gonna come up on the end charge here. And we are gonna go ahead and reset the values once it kicks off. You'll see the amperage starting to drop now. So we'll go in and clear the data now. All right, everything's clear. Go ahead and disconnect the charger. Go ahead and connect the inverter. All right. So the inverter and everything plugged in is drawing about 4 watts right now. We'll get it powered up and we'll check the loss in between. So we lose about 3 watts in between the battery and the inverter with everything plugged in. We're just gonna run up the wattage real slow here. Make sure we capture everything. Now the max draw on this BMS in here is apparently 50 amps. So that's about all you get out of it. This should climb up here to maybe 25 or so amps. We'll see. Alright, we're at 26 amps drawing out of the battery. Just 350 watts or so, and we're getting about 320 to the actual output of the device. So losing about 30 watts in between for loss. Run up another device real quick. Alright, so we're pulling about 34 amps out of the battery. DC, that's 34 amps DC. 12.9 volts, 441 watts coming through the shunt. We should get about 3 hours out of this, it says. About 400 watts AC, drawing 3.6 amps AC. 60 hertz, 114. So we'll just leave this here and let it run down and come back and check it. We'll set our stopwatch now. Come back and check it maybe every half hour or so and see where we're at. Alright, we just did the math between the loss on the DC to the AC side, and we're getting about an 87 to 89% efficiency rating. Which is not bad because it's right on point for everything. The inverter is 90% efficient, so take it how you want, but it's decent. Just wanted to show it's pulling down 12.8. 12.8. So it's doing good. Alright, we're still drawing down 370 watts, 12.8 volts, 33 amps. It says we took out about 34 amp hours already. We have about 100 left, 74% of the battery. Let's look here. 3.5 amps, 0.38 kilowatts, and we've been running an hour. So we'll let it keep going. Alright, we've been going for just over 2 hours now. 0.78 kilowatt hours or 780 watt hours so far. 12.68, still drawing down 34 amps. Got about half the battery life left. We've drawn out 69 amp hours. We got 65 left in there. And like I said, this is just over 2 hours of pulling a constant, almost 400 watt load. Alright, what we did was we just cut the power down a little bit, just to see if it would go back up to 1288, and it did. As you can see, when we put it under heavy load, that voltage will drop. We've drawn out 1 kilowatt, just a little bit over of a kilowatt. 43 amp hours remaining, or 32% of the battery, and we've drawn out 91 amp hours, it says. So we'll just let this thing kind of sit here at about half or so of the voltage or the wattage we're pulling, between 150 and 200, and we'll come back and check it in about 30 minutes. Alright, we've been going almost 4 hours now, 1.17 kilowatts, 12.79. We're gonna up the amperage again on here. 22% of the battery left. Drew out 104 amp hours already. So we'll see what we get. Alright, it's been going over 5 hours now. 1.48 kilowatts, 11.15 volts. We have 1% theoretical left of what the battery is. We've already pulled down 132.88 amp hours. It says we have 2.1 amp hours left. We're not sure when this BMS is going to cut off though, so we'll just leave it for now.
We turned up the heater just to see what's going to happen.
All right, there we have it. Low protection was kicked off. All right, everybody, after crunching the numbers, here's what we ended up coming up with. We were able to pull 98.8% of the total 135 capacity. We pulled about 133.5 amp hours, so that put us at 98.8% efficiency, or power pulled out of the battery. So that's right on spec with what it's supposed to be. We'd like to see it a little more, but in reality, that's right at the 100% mark because of inverter loss and cable loss and all that. The actual inverter efficiency out the other side was 86%, so quite lower, but that's the inverter's fault, not the battery's fault. We produce 1.50 kilowatt hours AC, so this battery provides 1,728 kilowatt hours. We were able to convert it from DC to AC and get 1.5. So 228 watt hours less than what it was specified. That's right on point with what loss you're supposed to expect through inverters, meters, and all that stuff to your end result. So at 98% or 99% pulled capacity, the battery did great. And now we would just look for a better inverter if we want to do anything. These batteries would be more marketed for something small scale, as it's only a 50 amp BMS. It doesn't look like it has any protection, like they talked about a heater inside there. I think this one does not have it. It's only different types of batteries they sell. It has to specify it. So good for small scale stuff, maybe a tiny home, maybe a backup power to a freezer or refrigerator, and that's really about it. 50 amps is not a lot. You're only talking 600 watts. So it's not gonna run any real coffee makers or anything like that. It's not gonna run a big refrigerator or anything like that. So keep it small with this and you should be good. We got some plans for it, so you have to stay tuned. Hit the subscribe button, notification button. As always, thanks for watching. Please subscribe.